Yeah, so good afternoon, Dr. Archana. So we welcome you at NIT Jalandhar. And Dr. Archana is a principal staff scientist at CERN. So we welcome you here. So, ma'am, can you please share your journey from India to becoming a principal staff scientist at CERN?
It's a long journey, an arduous one at that. It started in Jhansi, where I did my schooling, and then I went to Varanasi at BHU, where I did my graduation, continued with my PhD at Delhi University, and from there I went to CERN as my first job, if I can say so. And I stayed there ever since. I got opportunities and I converted them into my career step by step. And clearly, being an Indian at CERN is never easy, even today. And in those days, for me, it was going from contract to contract. But fortunately for me, I could work in the same field for 10 years, 12 years. And that's what gave me a good grounding and foundation to become a radiation detector expert, which then paved my way to the career that I have at CERN as a scientist. Yeah.
So, what were the biggest challenges you faced being at the biggest laboratory?
Biggest challenges, I can't really say this one was the biggest or that one was the biggest, because every challenge that comes with a solution eventually. So the very, let's say, in the face challenge was not being prepared. This is a world I'm talking about in the late 80s and early 90s, where it was not the world of internet and Google and all that, where you could be prepared to go outside the country and know exactly what kind of rules to follow. So environment, culture, all these things were very, very different. But apart from that, when it comes to my own preparation in terms of being ready to work in the laboratory, I found myself really lacking. And that was my biggest challenge. And every single day, I just had to work hard to fill up those lacunae so that I could move ahead in my career.
Okay, thank you. So, could you please explain in very simple terms which experiments in CERN are important to humanity beyond understanding fundamental physics?
Well, if the electron was not discovered, they would not have had electricity. If we had no electricity, there would not have been life the way humanity enjoys today. We can stretch the argument where we can say that if WWW did not exist, the world would have been another place now. By the discovery or the invention of connecting the whole world with the web, that has happened because of the experiments at CERN, we are able to live in a society which can look after each other. COVID came as a bolt from the blue. If we were not ready with the technologies that were needed, we would not have been able to cope with COVID in such a way that we did. So everywhere you look around, whether it's touch screen or it's the web, as I mentioned, or the hospital implements and the imaging devices and so on, therapies included, they come from a world where experimentation happens. And at CERN, there are small experiments and big experiments. You may have heard about the Large Hadron Collider and the large experiments like ATLAS and CMS, where I work. There are also smaller ones like the antimatter factory, and in the antimatter, it's not fiction. It is used for PET scans. And everywhere you look around yourself, whether it's the airport or the hospital or security at your home or your mobile phone that you enjoy every single day, laboratories like CERN spin off technologies for humanity.
Okay, so these days everyone is talking about artificial intelligence and machine learning. So, how is artificial intelligence and machine learning taking shape in high energy physics?
So let me reverse the argument, in fact, that what we do at CERN is that we collect data from a large number of collisions from particles that go around in the Large Hadron Collider. This data quantity is huge that humanity has ever seen, and that we are doing since the last 30 years. The need for sharing data gave rise to the World Wide Web. The need for pattern recognition in the data that we've been collecting gave rise to neural network and cloud computing, and all these are precursors to the artificial intelligence that is now taking the world by a storm. So it is actually the other way around, I would say, and we are training our data more and more, training our algorithms more and more, so that we are able to look for new signals and new physics and new phenomena.
So, ma'am, like being in NIT, how can you encourage the students, or how can you tell that how NIT institutes like NIT can contribute to big projects like Large Hadron Collider?
So, first of all, I do believe very firmly that it is collaboration which is now the new competition. And in India as well, we need to come together and collaborate for whether it is for experiments at CERN, for example, and small institutes, big institutes. Every single student is a potential Einstein, I would say, because they have the capabilities. They just need to find the environment where the fertile ground where they can grow. So I believe that there is huge amount of potential to collaborate and participate, contribute to any of the experiments that are happening at CERN or on the planet for that matter.
So, finally, what legacy would you like to leave behind as a scientist working at the frontier of human knowledge?
Well, the legacy I think is in the students. I would say every one single student that I could inspire is the legacy that I would like to leave behind.